Hello everybody and welcome back. We're looking now at question 23 on the Pascal paper from 2017. An Anderson number is a positive integer k less than 10,000 with the property that k squared ends with the digit or digits of k. For example, 25 is an Anderson number because 625, which is 25 squared, ends with 25. But 75 is not an Anderson number because its square, 5,625, does not end with 75. If S is the sum of all even Anderson numbers, what is the sum of the digits of S? Okay. So the 25 example is just really there for clarifying Anderson numbers. It doesn't actually help us with even numbers. So let's say, suppose k is an Anderson number. Well, what are we to do? Well, we're actually talking about even Anderson numbers, and that gives us sort of a starting place. So suppose k is an even Anderson number. So k ends, and k has to be positive, correct? Positive integer. So k ends in a 0, 2, 4, 6, or 8. I guess it actually doesn't matter whether or not we take 0 to be, like, I know it says k has to be a positive number, but k equals 0 is clearly an Anderson number, but it's not going to affect the sum. So that was what I was worried about. Anyway, so k has to end in one of these. So k sort of looks like some other stuff. So, a could be, k looks something like this, for example. And a can be just whatever we want. If it's 56, we're looking at the number 562. The point is we have the single digit, the units digit sort of singled out. Because when I square k, I want to be able to have that singles digit kicking around. So we'll get 100a squared, and that will not have a tens digit or a units digit, plus 20a plus 0 squared. Well, this ends in a 0. Hurrah! So that's some useful information. K squared 10a plus 2 squared, well, that's going to be 100a squared. And now it's going to be plus 40a plus 2 squared, which is 4. But that's going to end in a 4, not a 2. So no Anderson number can end in a 2. We learned something. Yay. Let's try the other ones. K squared is 10a plus 4. We square that. We'll get 100a squared. Don't really care. This would probably be a perfect question for something like modular arithmetic, but don't worry about that right now. Plus 16, so this will end in a 6. So no Anderson number can end in a 4. K squared, by the way, in a moment I think we'll show that no Anderson number can actually end in a 0, but right now it looks like it could. But the second you end in a 0, your square will end in 2 zeros, which means you had to start with 2 zeros. But the second you end in 2 zeros, then your square has to end in 4 zeros. And it just gets messier. So we'll be able to show nothing ends in 0. And I'll probably get lazy and use the exact same argument. But so we put a 6 in there. 2 times 6 times 10, 120a. Plus 36. Now this ends in a 6. So an Anderson number could end in 6. And our last possibility, 10a plus 8 squared, is 100a squared plus 160a plus 64 ends in a 4. So only ones that could be Anderson numbers are numbers that end in 6 and 0. Now, k can't end in 0, because if k were, 10a plus 0, which is really just 10a, k squared would be 100a squared, which ends in 0, 0. So therefore, k is not going to be a single digit, because we said k can't be, k has to be positive. So therefore, k ends in 0, 0. But then k is going to look like 100a, and then k squared is going to be 10,000 a squared, which ends in 0, 0, 0. So k ends in 0, 0, 0. 0. And then you can repeat, so k's got to be a multiple of 10,000, but then that's beyond our range. And of course, you can keep repeating the argument to show that you'll never actually get an Anderson number this way, other than k equals 0, which technically isn't one because of positive integers. So that means that we can only ever have Anderson numbers that end in 6. Okay, and can this work? Well, yeah, actually it can. K equals 6. K squared is 36. So 6 is an Anderson number. So now, and that's going to be the only single-digit one. Now let's suppose that k is a 2-digit Anderson number. So k is, and it will actually have 10a plus b, and this time a will be a single digit, as opposed to before when I didn't really care. So 100a plus, oh, and it won't be plus b, it'll be plus 6. So it'll be plus 120a plus 36. And so that will be 100a, doesn't contribute to the digits at all, plus another 100a, doesn't matter, plus 20a plus 30. So that's 2a plus 3 times 10 plus 6. So 2a plus 3 must end in an a. Okay. So when can that happen? So 2a plus 3. A's got to be a single digit. Well, I guess it still doesn't really matter. So, if A were a 1 or 2 or 3 or 4 or 5 or 6, we'll do more than in a moment, but we'd get 5. That's not going to work. 7, that's not going to work. 9, no luck there. 11, nope. 13, 15. What if I had 7, 8, and 9? So 2 times 7 is 14, plus 3 is 7, so it's going to be 17. So 76 would be a fine Anderson number. 8, that's going to be 19, ends in a 9, that's no good. And 9 times 2 is 18, plus 3 is 21. So A ends in a 7. That we can say for sure. So 76 should be an Anderson number. Well, if k is equal to 76, so I'm liking that the Anderson numbers are clearly building off. So 6 was the only possibility for the single digit. Now we find 7 is the only possibility for the second digit, the tens digit. And we'll just verify 76 squared is, k squared is 5776. So that works. Hurrah. Okay, so there's only one Anderson, one 2-digit Anderson number. Okay, well, let's keep going. Suppose k is 3 digits or more. Okay. Then k looks like 100 times something, and it's got to end with this 7/6. No other way about it. So then we get 10,000A plus 2 times 76 times 100. So that's plus 15,200A plus 76 squared, which I just had 5776. Alright, so we know the 7/6 is fine. We don't care about that. We just want to care, we care about what's the hundreds digit. So the 10,000A doesn't matter. The 1,500 or the 15,000 part doesn't matter. So it's just going to be 200A plus 57. But so it's just 2A plus 57. And this must end in an A. Alright, well, same thing that we had last time. We're just going to keep getting charts here. So A could be, well, it can't be 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get 59, we can get 61, 63. Ooh, useful. 65, 67, 69, 71, 73, and 75. It looks like there's only ever going to be one each time. We could probably prove that, but we're not going to worry about that. So hundreds digit is 3, so 376 should work. 376 squared, yeah, ends in 376. Okay. So if we want to be less than 10,000, at most we have 4 digits. Well, we've already done the 1 digit, the 2 digit, the 3 digit. Let's finish this off with the 4 digit Anderson numbers, if there are any. K has more greater than or equal to 4 digits. What do we have there? So it's got to end in 376. So it's 1000A plus 376. And then when we square that, we get 1,000,000A squared. I don't think I had the squared on the other side. Doesn't really matter. 2 times 376 times 10,000, or times 1,000. 752,000A plus, and then 376 squared. 141,376. So if I just want the thousands digit, and I can ignore this part, I can ignore this chunk and this chunk. It's just going to be 752A plus 141. But the thousands digit is just the units digit of this. So we'll choose our A, 752A. Of course, the 75 don't really contribute either, so and neither does the 14. So it's just going to be 2A plus 1 that we care about. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2A, 3, 5, 7, 9, 11, 13, 15, 17, 19. So there we go. So 9376. And we just double check. 9376 squared ends in a 9376. So the Anderson numbers are 6, 76, 376, and 9376. And if I add them all up, I get 9834, and we wanted the sum of the digits, as I recall. Sum of the digits of S. So 9 plus 8 is 17, plus 3 is 20, plus 4 is 24. 24 is our answer, and that is E on the end there. So there you have it, and that finishes off question number 23. 2 more to go. I will see you guys in the next video for question number 24. Thanks for watching.